My name is Sergey. I'm going to present today about transformation, like how to migrate transformations from our relational data warehouse to Spark and Scala. And sorry, click. Oh, yeah. And before I start, first of all, feedback. Yeah. So this is linked to feedback on this session, and please, I will show you it at the end of the session as well. And please leave your feedback because it's important for uh, organizer and for me to improve conference and sessions. About myself, I'm working as a lead big data engineer at Amazon in Seattle, and that's why you may see I still have the day. It's just early morning, and uh, I was the MVP, Microsoft Data Platform MVP for 6 years. So now because I moved to Amazon, I can't be MVP anymore, and I joined it MVP Reconnect, which is something similar with less sensitive information. This my contact after session. If you will have any questions and you need more details, please feel free to reach out to me, and I I will answer your questions. So I have been working with data warehouses for a long time, and last 4 years I'm working close with Spark and data lakes. And actually, we did migration from Oracle data warehouse to data lake with using Spark and Scala as a main data processing engine. So everything that I'm talking today is based on real experience, and I hope it will help you to make decision and also uh, uh, help you to make your migration if you do it. So I want to emphasize some important things about this session, that I'm going to focus only about data warehouse transformations. So how to move data processing part to Spark and Scala. So I'm not touching data warehouse design. I've seen many sessions at this conference about data warehouse design, data lake design, lake house design. So I think it's enough information about it. And also, I'm not going to talk about how to implement data warehouse specific approaches or processes like incremental loading or incremental processing, like slow change dimension and everything else. Yeah, because every of this topic, how you can implement it on Spark with Scala, it deserves separate session. Yeah, today I will talk how to begin with transformation part. Yeah, how do you transfer some concepts from a relational database to Spark and Scala. Yeah. And if you have questions during the session, please ask. So I, I, I would try to answer it during the session, but we will have questions at the end. What we're going to talk today is minimal requirements. Yeah, because migration uh, migration from similar technologies, yeah, it's usually more about how we transfer what we already have. Yeah, but when you're moving to completely different technology stack, yeah, sometimes it makes sense to have minimal requirements for your data warehouse for your project. Then we talk about motivation because, again, more migrating to completely different technology stack is like big decision, yeah, and you should have great motivations for this that you can present to your stakeholders and sponsors. We will talk about technologies, yeah, technical part, about concepts, architecture, code, how it looks like, and at the end we will talk about development process and testing. So minimal requirements. because we're migrating to differently like technology stack, like big data stack from let's say relational data warehouse or MPP data warehouse, uh, you may see that there is some minimal requirements that like a bottom line. Yeah, if you have less than those minimum requirements, it doesn't make sense to think about migrating to this technology stack at all. It won't give you any benefit. It will just increase operational or development process. Uh, it, they don't give you, they won't give you any benefit from data processing perspective. Yeah, and as any data, a big data world or MPP even, yeah, there is a minimum line for your data volume. Yeah, and from my experience, I would say it's more than 100 gigabytes at start. Yeah, if you already have less, it may not give you all those benefits. It wouldn't be worth all those efforts that you need to change completely technology stack, learn new uh, technology and approaches. Yeah, just processing like 10 gigabytes of data. Yeah, and this is generic for I think for everything, even for I remember when I started working with uh, Azure Data Warehouse, right? So 100 gigabytes it was let's say minimum that you need to start. And another one is data growing. Yeah, so from our experience, it's like more than 20% per month. Yeah, because with this velocity, you will grow pretty fast and you will need more capacity, you will need more power to process this data. And then Spark will help you with this. Uh, because you're migrated to new technology, right? It should be support from top management because you will need more effort than just lift and shift to similar SQL-based technology, right? So you need great support from your top management for this because it will take time and they won't see uh, quick benefits immediately. Yeah, you should explain it. And the last one, weight all pros and cons, and that's where your motivation drivers are important. Yeah, that's where you weight your benefits. Yeah, and if your benefits outweigh all drawbacks that you see, yeah, then this is like trigger for your decision to start migration. So motivation drivers, yeah, this is your architecture drivers or motivation drivers that gives you idea what is your benefits and what are drawbacks. Yeah, but mostly about benefits. What we found benefit from ourselves, yeah, because we did it migration from Oracle, like Datawarehouse based it on Oracle, yeah, and we found that we need scalability, right? So we need because data is growing pretty fast, and every time like revise how many processors, how many power we need for this data warehouse, yeah, how we need to restructure data or something else, yeah. Uh, we need more efforts to implement it in Oracle rather to migrate to Spark, yeah. And it will give us also parallel processing. So that's what we are meaning by scalability, right? So we can process our data uh, multi years, yeah, and parallel without uh, performance downgrade. So second one is provide business new possibilities. Yeah, when we usually think or design data warehouse and relational, and we also always ask questions our customers about what kind of granularity you want to see of data. Yeah, and we try to squeeze this granularity because we don't want to store data that we don't need, or maybe we need it pretty rarely. Yeah, because storing everything in relational data warehouse, it's pretty expensive. Yeah, and also system will work. BI system will work faster if it needs to query a small amount of data. With uh, but with this approach, we hide from our business holistic picture, because sometimes they want to dive deeper, but we can't provide this data. We can't uncompress our aggregated data. That's why all this data lakes, when we store a data, every data on lowest level granularity, right? Where we store it just on the storage, blob storage, we pay less money, and it's less expensive. Yeah, and we provide more information, more ideas for data scientists and from business, how to improve business process when they look to this more granular data. And that's what was our motivation. And actually, when we start implementation, we just migrated uh, transformation as is. So they included all this data aggregation on higher level, and it was small amount of data. Yeah, we even start thinking that maybe it doesn't worth to use Spark for it. Yeah, but when we start removing all those aggregations and keep data on a lower level granularity and processing data on this lowest level granularity, we find out that actually we have huge amount of data, and it grows pretty fast. And the business start generating, as they start accessing this data, they start generating more ideas how to improve processes and how we can implement additional transformations or even collect additional attributes that helps them to make decision. Third one is minimize costs. We want to eliminate any licensing, so we don't need Oracle licenses, and release any resources like virtual machines that we don't need. We want to use our processing power on demand. Yeah, so we pay for what we use. And the last one is agile development, with everything keeping in the data warehouse and using SQL. It took about weeks and months to deliver new functionality. Yeah, and because your data is squeezed, you always need to come back to the source and work from the bottom and find how you can deliver this functionality with keeping data in lowest granularity. And the same, working with SQL, it's not very convenient for multiple developers working on the same feature, and also working on code reviews, planning releases. So we start looking to more software development process, how software development works, and try to apply it to our system. And it was pretty easy because we start using Scala, which is functional programming and object-oriented programming language. Right? So as we write our transformation in Scala, it starts easy to apply all software development approaches and skills. Yeah, so we can use branching, feature branching, we can use normal code review process and release and deployment. Yeah, and we can apply agile development pretty easy, because again, all our processes is the same as software development process. Any questions? Maybe. Okay. Uh, Main concepts of architecture. Yeah, just to understand what components difference you may see, and it's not really big difference, right? The closest is I will to MPP data warehouse, that where you have lead node, you have compute node, which is scalable, right? You can scale up, scale down on demand even, and you have storage, everything decoupled, compute from storage, you can scale independently, everything is good, right? Uh, Big data, data warehouse, or data processing, it's similar, right? We have also storage decoupled from compute, storage, but we have more choices what storage may be, or it's HDFS, or it's a different cloud blob storages. Yeah, so if we want to move from one cloud to another, it's pretty easy. Compute, the same. We have master node and worker nodes. Yeah, it's scalable, similar to compute layer in MPP data warehouses. Yeah, and one small, and again, we can run this Spark compute on any compute resources. Yeah, I mean, in any cloud. We're not closed to vendor. And one difference is the metadata layer. Yeah, usually in the MPP data warehouses, your metadata embedded in your data warehouse solution, right? When you create tables, views, stored procedures, set everything on the same database. And big data, this layer is decoupled. Yeah, you're using Hive Metastore to uh, store our metadata. Yeah, and then compute layer is not coupled with it. We can stop it. We can move it. We can use another compute layer. So we can connect, let's say, for processing, we can use Spark. Yeah, if we want to query data, so our customers, they are not uh, closer to this technology. Yeah, they can use actually something else, like Hive, to query this and process data or query data. They can use Athena, they can use Redshift, they can use uh, everything else that can connect as external table to Metastore. Yeah. So more flexibility that you can pick and choose on every layer. But in general, it's the same. Yeah. Let's dive to particular components. Yeah, and what is the difference you may face when you start working on it. In a data warehouse, yeah, MPP or relational, you see you have table definitions. Yeah, and it's, as we discussed before, it's coupled in, it's embedded in your solution, yeah, in your technical stack. And in Spark based, yeah, it's decoupled, and usually it's some sort of or Hive Metastore or some cloud specific solution, but they mostly base it on Hive Metastore, right? So, for example, Glue Data Catalog in AWS. Transformations, again, in a data warehouse, your stored procedure functions, everything in your database. Yeah, so you access it from there. And when you need to move, you need to think about what SQL specific use it in another technology. Yeah, in Spark you just use, and Scala you just use methods, classes, and it's compiled to jar file, and you can move it to any Spark cluster, so it's cross uh, supported, and any platforms. Yeah, so it's easy. And the same, it's code management is easy because it's the same as software development. Storage, again, you have usually internal data formats, mostly columnar, which is the best for data warehouse workloads. In Spark, storage is decoupled, yeah, so you can pick and choose what technology you want to use to store and what cloud service, and uh, and you need to use the same columnar formats, but it's not like closed formats. It's more public available and known like Parquet or C. Yeah, but Parquet is more popular for this. And partitioning, again, you're working with tables and internal storage. In big data, you have partition on storage. It's like just prefixes, just folders or catalogs, right? So it's easy to move from one place to another, reshape it, yeah, because it's just the same as any storage. So it's not embedded formats, everything else. Compute, yeah, in MPP we have scalable engines, the same as in Spark, and maybe always allocated, it's not real. Now we have actually cloud solutions that provides us on demand dedicated resources, right? But Spark, it's always like on demand. You can allocate what you need, yeah, and scale up, scale down. It's pretty easy. and and it works on any platform the same. Yeah, so if you move from one platform, one cloud to another, it's the same. And encoding, yeah, usually used in Datawarehouse SQL-like language. Yeah, it's now we have many tools that simplify development with SQL, similar to software development, but again, additional expenses, right? Additional tool sets, and it still doesn't provide this convenient way to organize team development when you work on this. Multiple developers work on the same feature or they work on the different features, but there has dependencies. Yeah, and organized CI/CD. And the same with Spark. Yeah, you can use Scala, which is object-oriented or functional programming language. So you can use both features at the same time. That really provides a great benefit how you structure your project and how to implement parallelized execution in Spark. And you can implement really complex things there using those possibilities. And yeah, easy for team development because it's just like software development. Uh, so here I would like to dive to more about how it's implemented, yeah, how it works. And I have a few slides, but I will switch to demo. Yeah, I will raise it to show you how it looks like in the project, in the code, yeah, and then we can come back just check all points. Any questions so far? Okay. So in your local machine, and uh, like it works from any like Windows or Mac OS. You are not coupled with this. Uh, you have you need Spark. Yeah, you need your IDE, like IntelliJ. I I I found it's the most convenient tools for this. Yeah, for any Scala development. And for Spark installation on local machine, it's pretty easy. You just download uh, source code, compile it, libraries, you place on your disk, and you specify environment variables. Yeah. So I just use Hadoop home and Spark home. That's how my system now knows where to find libraries and engine. So IntelliJ will automatically recognize it. Uh, Project you're building, there are two ways how you can like build build frameworks that you can use to organize project. It's or SBT or Maven. Yeah, I use SBT project, and so I found it's pretty easy when you're moving from databases, regular traditional data warehouses. Yeah, it's pretty easy to understand SBT. Yeah, Maven was more for Java development. Yeah, that's why it may have a bit complex structure, but SBT was built for Spark development, so it's much easier. So you're adding, as in any software development, you need to add your dependency. Yeah, and dependencies, it's the libraries that you want to work. For Spark, you will need to Spark Core, Spark SQL, Spark Hive. Yeah, and sometimes you will need additional libraries. For example, if you want to directly connect to SQL, you can use Spark Connector. For SQL, you can optimize your uh, parameters. So then you need additional scala library. You want to work with JSON, yeah, and your unit test. That's how you, if you need additional functionality, additional library, that's how you can add it here. Another one is project structure. Yeah, uh, I'm using a worldwide important example, uh, imports example. Yeah, so that's what I have in my SQL, this is my importers, like OLTP database, this is my Datawarehouse. Yeah, and I am creating my project as this one, and I'm structuring my code that we found is this structure is really convenient, because when we started, there were no information about how you actually structure in your Scala, Spark Scala project that you're building for data warehouse processing. Yeah, it was mostly like how you need for Scala development, regular like parallel processing applications. Yeah, but it wasn't so applicable for data warehouse. So we came up with our own structure, which is common. It's everything that is reshared across different processes, and it's mostly some constants, and where we start like just literals. And this is where we need to remember about best practice, that you're not hard coding any literals, any values in the code itself. Yeah, you're or creating constants or some enumeration, some libraries, some dictionaries that you can reuse. Because if you reuse it multiple times and you need to change it, it would be hard to refactor everything where you use or find where you use it. If you store it as a constant in a single place, if I need to change this name, I can easily change it only here. If I need to change name of my constant, I can easily use refactor rename, and my studio, it will automatically rename everything where I use it. So this is like great benefit of software development tool set, yeah, that you can refactor pretty easy things. Yeah, that's why you need constants. So we're not using any literals in our code. Everything goes through constants or some dictionaries. And next item is a domain. Yeah, so we discussed that table where we're describing in database, right? We're creating our table with create and list columns and data types, right? And then when we're writing SQL, it works in IntelliSense. It helps us, yeah, and we see all our data structures. Yeah. When you start working with Scala, it's not database, right? It doesn't have connection to metadata layer where you can just expand some folder and see all your tables. Yeah. So you can do it actually like when you develop on local machine, right? But if you work with dependency, and again, when you write code, code doesn't know about this. That's why you need domains. Domains describes what are you your structure looks like. For example, this is my staging tables, right? And I define my table structure like this. So this is my fields, yeah. And when I start writing some select, let's open my data warehouse transformation and any processing. Yeah. And when I write select, right, I don't know what my field name, what fields are available for this one. Yeah, if I use my text, yeah, I will just hard code every names, and then hard to again change it, hard to navigate. With defining domain, I can access it like any field. So using IntelliSense, I can see what field columns are available for me. Yeah, similar as I work with SQL. So that's why domains are really important, and you need to create it for everything. And it has additional functionality, like you can define schema, and then when you read data without headers, you can use the schema, and you can extend additional uh, functionality to here. If you know that you query this data with particular schema, like particular list of columns, you can define all these columns here, and then when you're querying it, instead of enumerating every column, you can write something like select and then my columns. Yeah. Wait, this names it is column list, right? It's it is say I want to write my select and then list like this. Yeah. So actually I didn't import this library, that's why it's red. Yeah. But this is how you can select all columns for this particular schema. Sometimes we have aggregations aggregations for different granularity. Yeah, that's where we use this feature. Or we define different granularities of data, and then we can use this column list for group by or select. So that's how we define domains and all our structures. And another very important things is schema, right? So sometimes you have your data comes as CSV, TSV uh, without any schema, right? Headers. So you don't know your headers, but you need to import it and use it. That's where a case class would be important. Yeah. So case class, you're again defining your table structure, right? And when you read your data without headers, one example is, let's say, this my that's what I read from Datawarehouse already. Yeah. But if I read my raw data, my reader, uh, so when I read it, I can define my schema, right? So actually, when I read my CSV or TSV data without headers, my case class will apply all the schema. And when I read it finally, I have all my headers so I can work and address my columns. Otherwise, without headers, it will be like column 1, column 2, column 3. So that's how you can implement reading data without headers. Yeah. If you have headers, it's much simpler. Another important thing that helps you, yeah, so you're defining your schema and now you're ready to start writing your code that will read data, yeah, is you need your source destination, right? You need to specify what is your store source destination database, let's say. Yeah, the same when you write it, you have OLTP as a source, Datawarehouse as destination. You know, in our case, because we store everything in high meta store, yeah, we will have different databases, separate database for staging and separate for uh, yeah, yeah, I see. Thank you. So when we're storing processing data, we're reading from our files and we store into our staging table. Yeah. For this purpose, I have my row to staging. And as we see in readers, I read my data and for this I use location. Yeah, because it's just files, drop it uh, to my storage. I use location and I read it using my schema, and now I using this one I can save it to my staging data lake database, right? So that's where using here, that's how my row to staging works. I read everything that I need, and it returns me a list of what data sets I read. Obviously, you can read one by one, like return one by one, and then like your code will be much complex because we will have separate line for everything. But that's how you can like using power of Scala and actually simplify it. Yeah, so you read everything and you return as a single list. and then you use tuples, which like your key value dictionary, where you have this list, and then you just using for each you can save everything, and that's where I save it as a table to my Hive meta store. Yeah. And then so it's just the same as a save table. It's like insert to table, right? After this, I have all my tables in my staging. Yeah. And because I save everything in Parquet, yeah, I have everything in my Parquet format. But that's how my local Hive meta store looks like. So next stage, I start populating my Datawarehouse. That's where I start using separate structure for a Datawarehouse. Yeah. So I have my row, I have my Datawarehouse where I have dimensions and facts. Yeah. Facts and with dimensions. Yeah. So I have my population code. So for every dimension, I have separate application. So it allows me then in my orchestration system, I can orchestrate it and run it in parallel or put dependency if I have dependency from each other. And in a dimension, because now my data already in my metastore, I can read data, right? I can read data and again write data to Datawarehouse. And to read and write, so it looks like save as a table and read table, right? But it's not native. So actually I pre-created it, and this is another component code structures that you need to pre-build when you start development. It's utility methods. Yeah, utility methods allows you to simplify transfer from SQL to Scala. Yeah, that's why you should have at least one experienced developer who will prepare it. Yeah, and in this utility methods, you will create methods for read, yeah, which is actually wrap up all the Spark read options, TSV, and you can create multiple readers with different parameters, like maybe somewhere you want to partition, somewhere you don't want to partition, right? So different delimiters or something. So you can create uh, separate methods for this. But the best practice is use polymorphism in object-oriented programming that allows you to create single interface. Yeah, as you can see, name is the same, right? But number of parameters is different, and also different options I use. Yeah. So you have the same interface, so you don't have to remember multiple methods that you need to use this to read TSV with delimiter tabular and another TSV with delimiter comma. Yeah, you can use the same interface, but when you start writing your parameters, yeah, IntelliSense will show you what parameters are available. So polymorphism is important. So you're pre-creating all these methods to read and also to save. Yeah. So again, save, you can use different modes, different formats, but interface is the same, right? Save as table. So when developer will start writing your code, they just need to remember that save as a table, that's how we store it. Yeah. Any questions? Yeah. Okay. The same about utility like joins. Yeah. And in Scala, yeah, in SQL we have like left join, right join, yeah, inner join names. We know by this name what it does. Yeah, in Spark data frame or dataset API, yeah, there is only one join, and then depending on what parameter you set up, it will be or left join or inner join. Again, to simplify it, you're creating your methods in helper, naming what is more convenient, like left join, right join, inner join, and you predefine all those parameters here. So when developer start writing, they don't have to remember what I should set up as a parameter. They can just use my right join or left join. Yeah, like here, I just use left join and my columns that I want to use as a parameter. So pre-creating utility method to simplify and make coding more close to SQL is really important. After you have all of this, start writing any like application is much easier because you will be close to how SQL works and how you write your um, code. Yeah. Every application has parameters. Yeah, that's where we specify what are our input output database, for example, or any other parameters. And we just use it inside. So that's how we receive our arguments from Spark Submit. Yeah, when we execute our code as a Spark Submit, we send list of parameters, and that's how we catch it inside, and then we can access it. Yeah, and that's where trait is important. Trait is like Scala version of abstract class. Yeah, so again, you're creating single interface for parameters, and I know that this parameter is my mandatory parameters. So when my developers they start writing parameter class, yeah, they inherit it from my required parameters. It means if I don't write this one, it will show me that something wrong. It's mistake. Yeah, you see, it highlights that it's mistake because there is a required parameter for this. So that's where traits is really important. You define your interface, you define your required methods, variable, whatever. Yeah, and then when developers start writing, it helps them understand what is the minimum methods I need to use for this if I inherit it. And the last one is transformation. Yeah, for transformation, you uh, simplify it with next approach. When you write transformation, you try to, the best practice, what we found is split your, let's say, effect. Yeah. So split your transformations by minimum items. Yeah. For example, I have my inner. Yeah. And if I need some additional transformation like filter, yeah. For example, I want to filter columns. I don't apply filter here. Yeah, I can use just my filter columns by column, and then I specify what column I want to read, like filter. Yeah. So it has two parameters. Yeah, it will show me that I need to use two parameters. Yeah, my column name and column value. And all your transformation you are staking as a pipe. Yeah, so you have my filter transformations, and I might have some additional transformation, and so on and so forth. Yeah, 5 minutes. Mhm. Yeah, yeah, thank you. Um, yeah, that's why all repeated transformation, everything, you're defining it as a separate calculations, so you can reuse it multiple times. Yeah, the main benefit is like decouple all your transformations to reusable chunks and then you wrap up it to helpers, and then you can reuse it multiple times. If you need to modify it, you need to do it in single place. Yeah, that's where all this OP or functional programming feature works when you have inheritance, yeah, polymorphism, that you can reuse code multiple times, you can refactor it, it's pretty easy. So, and the last thing is testing. Yeah. So actually, when you write your code, you need cover with unit tests. So when you execute, it will check your logic, and you don't have to worry about that code works correctly. Yeah, and that's where unit test is useful, where you define your mock data, you know, and then you write your unit test. where you just check some logic. You execute your transformation logic, and then you check, let's say, that I expect 6 records. So, and then I can execute it, and it will build my code and execute this logic with test data. And if it's passed, everything is green. Yeah. Again, when you run your CI/CD process, yeah, it will. So I changed code that it's failed, right? So when you write CI/CD, CI/CD process will execute all unit tests. So it's like automated tests. So let's go back session. That's what we discussed, right? Constant domain traits, how to define your utility methods, right? Split transformation to chunks and pipe them and wrap up everything to helper. It allows you to uh, first of all write code faster because it's like writing SQL transformations one to one. Development process, yeah, well, you can use development process as a software, yeah, splitting your code by hotfixes, master hotfix, and every developer creates feature, and then you just merge everything with merge request. So it's in tests using a test-driven development approach. You can write code faster. Um, Maybe at the beginning it will take more time, but at the end it's actually much faster because you make less mistakes when you write code when you already have tests. Yeah, and to summarize what we're talking today, discussing today is first of all, think about if you think about migrating your data warehouse to Spark, think about motivation. It's really important, and architecture drivers. Yeah, think about minimal requirements and all pros and cons. Without these two important things, you can just start project and it will fail. Yeah, because you didn't recognize, you didn't have enough motivation, you didn't enough support, or your minimal requirement doesn't fit, and you will spend more efforts for this. Invest to develop in developers trainings, yeah, to OP or functional programming, to Scala, right? And do your development iterative. So start small, write some small transformations. Don't don't take much. Don't think about code or how right it looks like. Then use refactoring and next refactoring and next refactoring. Yeah. So this it. So again, feedback. Uh, it's very important for improvements, and I guess also organizers for every 10 feedbacks they donate some amount of money to organization. Um, I think if I have, do we have any questions?
I think there are no questions in the room, and there's nothing in the chat. So thank you very much, Sergey, for your presentation, and have a good day.
Yeah, thank you guys. Have a good evening. Yeah,
Thank you.
good party. Bye bye.
Thank you.
Thank you.
Bye.
Bye bye. Materials available on GitHub, so all code if somebody needs it.
Oh, thanks. If you
And
just,
I publish.
yeah, if
I
you just,
publish. Yeah.
yeah, perfect. Thank you.
Yeah. You're welcome. Thank you, everyone. Bye bye.